is on the tangent ratio. The tangent ratio is, or just the word tangent in math, it kind of is connected to the sphere of math called trigonometry, which some of you will take next year, Algebra 2 with trigonometry, where you'll go into these topics kind of in a more algebraic sense, kind of separate from looking at shapes and figures. But tangent, trigonomic ratio, we just abbreviate it. Instead of saying trigonomic, we just say a trig ratio. We'll learn 3 of them in total. Today we're just going to do tangent. So a trig ratio is a ratio of 2 sides in a right triangle. So a ratio is we're comparing 2 things. All right, so like a fraction is a ratio. Division is basically just a ratio. You're comparing 2 things. So a trig ratio is you're comparing 2 sides of a right triangle. Why we can do this is because in all triangles, all right triangles with a given acute angle are congruent by our angle similarity theorem. Because if we have 2 angles that are congruent to each other, that means the 2 figures are similar to each other. So that's what we kind of have going on in this diagram here. We have these 2 right angles, angle L and angle Z. And then we have our 2 acute angles, angle J and angle X. They are congruent as well. So we could say these 2 triangles are similar. And if they're similar, what we've been doing is kind of writing these proportionality statements where KL over YZ is equal to JL over XZ. So talking about that this leg, KL, is proportional to this leg, YZ, and kind of our base leg. JL is proportional to our other leg. So if we can write it as this proportionality statement, we can rewrite it as this. Where now we're talking about, we're setting up a ratio between the same triangle. Because KL over JL, if KL is here and JL is here, now we're talking about a ratio in the same triangle. We could do the same thing, YZ and ZX. So that's why we could take similarity statements and then go to now trig ratios. And trig ratios are always talking about ratios between 2 sides of a triangle. In the tangent ratio, we're specifically talking about the 2 legs of the triangle. So kind of a key piece to remember with these was, since they're similar triangles, trig ratios are always going to be constant. So that means they're always going to be the same. And we'll see that as we go through and as you'll go through on the homework. So for example, I always know what like the tangent of a 60-degree angle is, because that is a constant number. And here's kind of the nitty-gritty. It's not a theorem. It's just kind of what the tangent ratio is and how to find it. So our setup is we have a right triangle, triangle ABC, and angle A is an acute angle. The tangent of angle A, and we write it as tan of A, so T-A-N of A. You may have seen there's a tan button on your calculator. You may have been wondering what that's for. We're finally going to use it. It's defined as the following. So the tangent of angle A, so one of our trig ratios, you can find by taking the length of the leg opposite of angle A divided by the length of the leg adjacent to angle A, where adjacent means next to. So here's angle A here. It's acute down here in the corner. BC, it's already labeled for us, is the leg opposite of angle A. Remember, we go across our triangle. And adjacent, meaning next to, would be AC in our triangle. When we use the word adjacent, we never talk about like if it's adjacent to the angle. We're always talking about one of the legs. We're not talking about the hypotenuse. All right, so Hypotenuse is kind of its own thing. When we're using adjacent as a term, we're always talking about one of the legs of our triangle. So to find the tangent of A, we divide those two. It's a ratio, it's a comparison between the two side lengths. So putting this into practice here, in example 1, we're going to find the tangent of angle S and the tangent of angle R. We're going to write each answer as a fraction and as a decimal rounded to the 4th decimal place. So this is, as we begin to practice this is kind of the setup that I would suggest using until you feel like comfortable that you can just kind of do this on the fly. Say we're trying to find the tangent of S. Well, to find the tangent of S, we have to take the opposite, the length of the opposite side from angle S, and also the adjacent side of angle S. So this is angle S. This would be our opposite side. And then 18 would be our adjacent side. Notice, like I said, I'm not using the hypotenuse, I'm using just the two legs when I'm talking about tangent. So now all we do is plug it in. We know that the opposite side has a length of 80. The adjacent side has a length of 18. So there's our answer written as a fraction. And then we want it as a decimal. We know to find a decimal from a fraction, you just divide the two. So when you do that and round it to the 4th decimal place, you get 4.4444. So now, finding tangent of R, I would set it up similar. Tangent of R is equal to our opposite side divided by our adjacent side. But now since we're talking about a different angle, which side is our opposite and which side is our adjacent is going to change. Our opposite side is now 18. And our adjacent side is 80. So we have 18 over 80. There's our answer as a non-simplified fraction. As a decimal, be 0.2250. Just dividing 18 by 80. So this is just basic kind of first step. How do I find the tangent of an angle? Well, you take the opposite leg, the length of the opposite leg, divided by the length of the adjacent leg. Let's get more interesting. Let's find values of x now using our tangent ratio. So instead of saying like the tangent of S or the tangent of R, I'm now going to use this degree measure that I have. All right. So let's say the tangent of a 32-degree angle. Well, that's still going to be equal to our opposite side divided by our adjacent side, where 11 would be our opposite. 11 is opposite of our 32 angle, and x is adjacent to it. So, like we did in the last problem, we can plug our values in. Tangent of 32 degrees is equal to the opposite, which is 11, divided by our adjacent, which is x. So now we have a little equation that we can solve for x now. Key piece to remember, tangent of 32 degrees, that's a number. All right, because this is equal to a ratio of our two side lengths. This is something you can put onto your calculator and you get out a decimal answer for it. So we're going to treat this just as a number. So when we're solving for x, we're going to move tangent of 32 from each side like it's a number. To start though, I want to get this x out of the bottom. So to do that, to get something out of the denominator, you got to multiply both sides by x. So multiply this side by x and this side by x. So when I do that, I'm left with x times the tangent of 32 degrees is equal to 11. Because these x's cancel out, they simplify to 1. All right, to solve for x now. This is x times, like I said, tangent of 32 is a number. So I can divide each side by the tangent of 32 degrees. Why I'm not putting this, like I could get a number and plug it in and replace it or substitute it in, but I'm trying to make my answer as accurate as possible, so I'm keeping this in here. So then we do that. These simplify to 1. So we're just left with x on our left-hand side. We have 11 divided by a tangent of 32 degrees. So moving forward, whenever you're doing tangents, or like really the next few days, everyone's going to need a calculator to do this. Tangent of 32, I don't think anyone really knows it off the top of their head unless they memorize that kind of thing. So on most calculators, the tangent button is to kind of like the farthest. On the right, usually it's by the division symbol. I think that's how it is on all of these too. Yeah, on this one, the tangent button's right by the division symbol. So on the pink ones over here, it's pretty easy to find. On most scientific calculators, on all scientific calculators, there's a tangent button. So if we're trying to figure this out now, you just put 11 on your calculator, hit your divide key, and then hit your tangent key, and then go 32. And then you'll get out a decimal answer and round it to the 10th. So it'll be 17.6. One thing you have to be careful of, I don't think anyone will run into this problem since you haven't used it yet. Your calculator kind of has two modes. It has what's called a degree mode and what's called radian mode. I'll let your Algebra 2 teacher explain to you next year what radian means. Big thing is, you gotta make sure that your calculator on the screen, if you're using kind of one of the ones that I have, it should say on the screen, it should say DEG, meaning that's in degree mode. Most calculators default to degree mode, so as long as you haven't been screwing around on your calculator, you should be okay. So final answer is 17.6. All right. Next piece, we're going to kind of do the same deal, but now we have a special right triangle because we have a 30, 60, 90 degree triangle. So the tangent of a 60 degree angle is going to be equal to our opposite side over our adjacent side. So this will be the square root of 3 over 1, which, if we divide anything by 1, it stays the same. So the tangent of 60 degrees is equal to the square root of 3. And if we approximate that to the nearest decimal point, you would get 1.7321. So this doesn't tell me how to round. I'll just do the fourth. And this is going to be a constant. If you take the tangent of 60 degrees, it will always be 1.7321. because it's a constant, because it's with similar triangles, it's always going to be the same. Those proportionality statements are always going to work out to be that value there. All right, last piece, as we usually do with notes. I don't do it on purpose, but we usually end with the word problem. So we're measuring the height of a spruce tree. You stand 45 feet from the base of the tree. You measure the angle of elevation from the ground to the top of the tree to be 59 degrees. Find the height of the tree to the nearest foot. So one kind of vocab term we got to talk about is what it means by an angle of elevation. So I always think of angle of elevation, and then its kind of counterpart is the angle of depression. So not that it's like a sad angle, but elevation, thinking like if you're looking straight forward, then you look up, you're elevating your head, so your angle is going up. If you depress your head, you're looking down, angle of depression. So this 59 degrees, think of this as like your eyesight. You look up, we have an angle of elevation of 59 degrees. And we can use that angle of elevation in our tangent ratio to find our height of our tree. So we could say the tangent of 59 degrees, well, that's going to be equal to our opposite side divided by our adjacent side. So our opposite side of the 59 is across our triangle, so it's H. Adjacent would be our base here, which would be 45 feet. We'll save the units to the N, so it's just 45. And then just how I solved, I got X out of the bottom by multiplying X on both sides. I'm going to get this 45 out of the bottom by multiplying 45 on both sides. So I'll take times 45 times 45. So on my left-hand side, I have 45 times the tangent of 59 degrees is equal to the height of our spruce tree. Again, treat this as a number. So you do 45 multiplied by, hit your tangent button, then just type in 59 and hit enter. You get out 74, approximated to 74.9 feet, but it asks us to round to the nearest foot. So nearest foot would be then 75 feet. So this is kind of most of your homework will kind of look like these type of problems. There's a few where it's kind of asking conceptually what a tangent ratio is. I think all of them you can think through.